Alrighty, let's see what we got here. Smallest subsequence of distinct characters, medium. Given a string S, return the lexicographically smallest subsequence of S that contains all the distinct characters of S exactly once. Subsequence. Okay. That contains all the distinct characters of S exactly once. BC, ABC, so it'd be ABC. So if there is, okay, yeah. Here has to have the D and it occurs only once. So I think it'd be like A, C, D, B. Yeah, okay. So if a character only occurs once, then it has to be used. Okay. So what's the logic here? So if a character only occurs once, it has to be used in that spot. And then if a character occurs multiple times, then you would somehow pick the spot that is best for it. So let's say there's a single D. The question is the same as 316. Remove duplicate. Right? Oh, yeah, I guess that's, yeah, you're removing duplicates, right? Um, okay, anyway. So if there's a B before and after the D, then you want to remove this B because DB is worse than BD. But if there was like an A here, then you technically want to remove this B because ADB is better than BAD. So what's the logic? So BDB goes into BD, but BADB goes into ADB. Do 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 do. So I think you start with the fact that D is there. Start with your uniques. Your uniques are going to be in the order that they are found. And then you look at the, I guess something like if you look at your optional, or your optionals are the ones that have multiple occurrences, the letters that have multiple occurrences, then you want to pick your smallest optional, your smallest optional first. So for instance, if it was BAD, BA, like technically the A is optional and the B is optional and the D is an optional. So in that, so like maybe you consider this as one kind of one bucket or the kind of the first branch of decision, and you pick the smallest of them, right? So you pick the A here. Because it would never make sense to pick the B in front of the A if you had a better choice. So if there was like a Z here, right? There was a optional Z. then you'd still pick the A first. So it's like this all is like an optional grouping. You pick the smallest of the optional grouping. I think that's right. I think that has to be right. Like, or I don't know, that has to be right, but that feels right. Like if there was a C here, right, and the C is not optional, then it really doesn't make any difference. But now this is all optional. The D is not optional. So amongst this, you have to just pick the lowest one. You have to pick the lowest optional. And then whatever follows that follows that. What happens if there's like multiple optional? Like what happens if there's like an A, Z, A here? Do I pick A and A? I think I do. All right, so if there's a tie amongst the lowest of the optional, then you just have to pick the tie. So it has to be like A here. And then like this B is no longer optional. This B has to be here. And then the DA is another optional group. What's the logic there? So I extend out the grouping of optionals. B, A, Z, A are all optional. And then I pick the lowest. And then I pick the lowest again. Can I use a heap or a stack? Or what? And what happens if there is like what happens if this is like the last Z? I guess if it's the last Z, it's no longer optional. Ooh, this is seems so simple given that it's a single line problem, but it's very tricky. A, V, A. So if there's only one of the character, I use that. If there's only one of the character, I use it. Maybe for every index, I count the number of that letter from that index onwards. I count the number of that from that thing onwards. C, A, Z, A. I mean, I could start by just creating the skeleton of the answer. The skeleton of the answer being the letters that only have one of them. Or I can try to build the answer and determine those on the fly. The only issue is like once you have an optional group where you're skipping a certain letter, like you're skipping the B in this grouping, then this B technically becomes mandatory. So maybe how would I adjust for that? How would I force that? So C. I mean, I could have a mandatory list. Okay, let's do a required set, and then let's do frequency is equal to the counter of F. So that gives me for each letter that appears, how often it appears. And then for every letter in the frequencies, if the frequency of that letter is equal to 1, then it's going to be required. Just doing a quick check here. B occurs twice, C occurs twice, A occurs once, A is required. Okay. And you should have A and D is required. Okay. C, B, so like C, B, in this case, you wouldn't pick either C or B because this A, you want to be at the start. Oh boy. So you have an optional group and then a letter after the optional group. And if that letter after the optional group is lower than all the letters in the optional group, then you want to remove, and you just want to ignore the optional group. Is that always the case? I guess so, right? I don't think you ever want to not do that. How would I know that this is all optional? Like if this was like two Z's, like ZZ, CBA, technically the two Z's are both optional. Technically the two Z's are both optional. Well, they appear optional because they're greater than 1 frequency, but then you can't remove both. You can remove one, but you can't remove both. Oh my god. There has to be some better logic than this, no? I feel like there's some better logic on how to figure out what the lowest thing is, but it is pretty short. It's only 1,000 letters. So I need to be aware of BCA, BC. This should be ABC. Delete BC from first optional group, where the optional group is BCs. Now, if this was something like ZZA, ZZA, BB, then this would be ZAB, the only one Z. Or even if it was something like, actually, what if it was like something like that? In that case, I guess that would be, you can't delete both z's, you have to keep one of the z's. And then if you want to keep the z, then therefore you want to make the b before that. Kind of rough. Z, B, Z, A, B, B. I wonder if this is just backtracking. Or maybe this is some sort of stack. Maybe this is some sort of stack, actually. Z, P, Z. So, okay. The answer here would be B, Z, A. Yeah, VBA. Feels like this might be a stack. Like, do I need to? Do need to worry about the A, right? The A does affect things. Because if it's BC, A, BC, then you'd want to delete the BC. But if it's Z, Z, A, and then no more Z's, then you can't delete both C's. Only delete one Z. Z, B, Z, B, B. Can delete one of these, but then you also want to put the B in front of that. Yeah, I don't know if this is, I don't know if required, that required letters is how I want to approach this. Feels like it should be some sort of stack, some sort of monotonic stack. Like you put Z on the stack, put another Z on the stack, put A on the stack, put a Z, another Z. When are you forced to decide? You're forced to decide when a distinct, when you have, I think you, well, maybe it's a sliding window. Like maybe you slide out the window until you see a distinct letter, or like all copies of a letter within your window. Like ZBZ, all copies of Z has to be there. At which point you need to actually determine what in that window or optional grouping has to be taken. So since ZBZ includes all copies of Z, then one of those copies has to be used. So you know that this is going to collapse into something with a z. And then at that point, you have to work around it. So for instance, if it was AZ, BZ, then you would pick the lowest before it, the lowest before the distinct. So if this was like that and there was more C's afterwards, then you have to pick BZ because B is the lowest value before the Z. But if it was something like AZ, then it'd be AZ. And technically if it was ABZ, then you pick ABZ before you try and find the, yeah, that feels like a monotonic stack, no? Try and find, you need to keep the A, you need to keep the B, you need to keep, technically like that, it'd be, you'd collapse it and get A, B, Z, A, B, C, Z. That feels like a monotonic stack, but then you still kind of want to know that there's a Z here, or somehow that this is the last distinct C. This was A, B, A, B, D, C, Z. Then it would still collapse into A, B, C, Z. Yeah, it's a monotonic ascending, monotonic increasing stack. So it's the monotonic increasing stack. A, so you have Z. When you push the A onto the stack, you check that there's a later Z after this. And if there's a later Z after this, then it pops. Then B, D, push B on the stack. If this is the final, yeah. If this isn't the final D, then D can go away and C can be pushed. So for every index, I need to know how many more letters, how many more of that letter occurs after it. How many more letters occurs after it. Or I can use the counter, decrement the counter. V, V, yeah, I think that's the monotonic increasing stack. Awfully tricky. So I need, and I think I do need frequencies. You need the counter. Okay. But then I think I need to have a done set. this is kind of distinct letters already added, already in the answer. Answer is going to be an array of characters that I'll append, so eventually it'll be something like answer, return the answer, was it join into a single string answer. I think that's how you do it. Yeah, that's the syntax. Okay. Okay, let's try it here. For every index k in range n, let's say letter at index k is going to be s at this index. And then eventually I need to do frequencies of this letter is decremented. And then here I need to check if this is required. So if letter is not in done, and the frequencies of this letter is equal to 1, then this has to be included somehow. Otherwise this is totally optional. I could always include some later version of this letter. Later instance of this letter. So if it is optional, then this goes on the stack as long as it's increasing, as long as it's bigger than the previous stuff, right? Okay, so I think it would be something like, I would like to have the stack always have some baseline. So I'll just include what's the baseline? Uh, 0. What's smaller than a? I think I just need to do a small check here. Is 0 smaller than a? Is 0 smaller than a? It is true. Okay. So yeah, this is just there's a dummy backstop. Or front stop. So the stack never goes empty. So else if it should be else if here. Else if the top of the stack is smaller than the letter, what if it's equal to? I guess if it's equal to, then you should also put it on the stack. And if there's multiple A's, then you want to put those multiple A's on the stack. Actually, should be else here. No. So if it's A, B, D, C, it needs to pop off the stack first, right? It needs to pop off the stack first. Is that right? If it's smaller than whatever's, if this is smaller, Z, A pops to Z, B, D, C pops to D, D, C. Yeah, C goes into the stack A, B, C. So what if there was another A here? It would be A, B, D, C, A. A would pop to C, D, B. Or if there was a B here. What's going on here? There was a B here, B pops to D. D, what's on the stack? It needs to pop everything that's smaller than on the stack and then push itself on the stack. It needs to pop everything smaller than on the stack and then push itself on the stack. So if the letter so while the last element of the stack is bigger than the letter, then stack.pop, and then stack append the letter. Is that right? Z. So if there's a Z, so if there was two Z's and those are the only Z's, then the first Z gets pushed onto the stack. And then the second Z is going to do this, code. And then otherwise, it's going to do this code. Pop everything smaller than off the stack. While the top of the stack is bigger than the letter, or the back end of the stack is bigger than the letter pop. It should go down to 0 if necessary. Append the letter. Okay, I think that might be right. Okay, and then so this one. So if this is the last of the letters, so it has to be required. So it needs to use the stack at this point. So everything on the stack goes onto the answer in sequential order. So this might be a queue actually, because I need to push it in chronological order, or from start to finish. Oh shucks. Okay, I guess this is. I have to use a queue. Queue would be the most. Yeah, I guess this is a queue. So go queue. Go. I'll just call it the fucking queue. Double-ended queue. I guess I can't use 0 as a dummy backstop because then that's going to be blocking my way in the queue. Okay. In that case, I think I need it whilst there is this. Oh, I need to call this queue, huh? I normally call my queue decks or double-ended queues. That's right. Okay, so if the backend deck is bigger than the letter, backend pop. I guess it should be if the deck actually is there, because there's no backstop to the 0. Okay, if the letter is not done and frequency of the letter equals 1, has to be included. So it should be move everything in queue to answer. So I think it should be while I wonder if I should just do an extend, really. The answer extends, but extends with the queue, with the stack, and then reset the stack. Yeah, I guess I should just use extend. It means literally just copying everything inside this array into the answer. Okay, going back to the stack. Oh my god. Going back to a stack without a backstop or a front stop. So I think this should just be answer extends by the stack. And then I need to add all the letters in the on the stack into done. Okay. Is that necessary? I mean, yeah, it's necessary. Now to add a list into a set. Update. Yeah, okay. So I wonder if I should be doing something like done, or maybe it should be stack.append this letter, answer extends the stack, extend by the stack, and then done.update with the stack. At that point, I should just say stack is reset. Stack append letter, answer extend by the stack. Done, update with the stack. Stack is reset. I feel like this might be it, actually. We'll see. Probably not, right? Fuck. Interesting. B, B, A. E. Right. Because A is smaller than BC. Then I just need to remove everything. Okay. It has to be included. I think I always pop. Yeah, I always do this. So while there's a stack and this letter is bigger than the last, pop, append this letter. Okay, yeah. If the letters that and that, it's already appended, answer extend the stack, update, stack reset. Okay, maybe that's the better logic. Okay, let's go ahead and just try a few more test cases here, especially the ones that I tested or mapped out. So ZZA, VB, VBD, ABB, and then the ABDB, the AB, let's say there's another C, D. Fuck. uh, ZZABB. Output here was, I see, ZAB. So if there's two Z's, how do I know if I want one or both? So ties I have including both. Ties I have including both. Because I don't know if ties I have including both because I don't know if I just want one or both. Right? In theory, if it was a small tie like AAB, then I want both A's. If it's a big tie, then I want only one A. Or like if it's ZZA, then I only want ZA. But if it was AAB, then I want AAB. So it depends on whether or not the next letter is bigger or smaller, which is annoying. What to do? ZZABB. I only want one Z, one B. So I only want one copy because the next thing here, A. So A is gonna go the second Z The second C is going to so I would only want the letter if the next thing is bigger than it. The next item that I include is bigger than it. Huh. The next item included is bigger than it. What is the way I can determine that? Like if I were to push, hmm, do I do a special check on the answer array before I do an extension? Before I do an extension, I check if the back end of it of the current answer has some ties, and if those ties are something that is bigger than the first item that I extended with here. I think it seems kind of hacky, but I think this might work. So if the length of the answer is greater than, I guess it should be while the length of the answer. So at least there's two elements in the answer, and the top is equal to the second to the highest. So the back two is the same. And the last element of the answer is bigger than the first element that I'm extending here. Then answer pop. I think that might be right. And then I need to do one last thing here. While length of answer is greater than 1. So for instance, if this ends up being like a bunch of B's at the very end, then answer back end are the same. Then answer pop. Fuck. Well, that handled this one, right? Accurately. Okay, what is the issue here? C, A, B, B. I had two B's, but it should only be one B. Interesting. This one I actually thought I wanted both B's, but I don't. Why do I not want both B's here? Do I never want duplicates? Do I never want duplicates? Is this not lexicographically smaller than this? Oh, is it not lexicographically smaller? My output was A, B, B, D, D, C. But it's saying that A, B, D, D, C is smaller. What? A, B, B, D, D, C. The string is smaller, then string B, if in the first position where A and B differ, string A has a letter that appears early in the alphabet. If characters do not differ, then the shorter string is lexical. If the first characters do not, if characters do not differ, the shorter string. Yeah. A, B, B, D, B, C. A, B. I mean, I feel like this is not lexicographically smaller. Okay, let's just have AI do it. Between strings that and that, which is lexicographically smaller and why. A, B, 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 D, Z, C is like what? So my output was this. What is going on? What? A, B, B, D, D, C. I mean, in the first position where it differs, the B is smaller than the D. And it still contains, oh, contains it exactly once. Oh, I never should have repeats. Oh my God. I thought it had to be at least once, not exactly once. Fuck me. Okay, then I just need to remove this. Remove all duplicates. So while pop, pop, pop. Okay. And also I can remove this. All right. I was losing my mind there. Okay. Let's see what this is. A, oh, yeah, okay. It has to be at once. Yeah, so let's see. Can't appear multiple times. So while stack. So if the letter is then done, then I just can't put on the stack. If the letter isn't done, then I can't put on the stack. So if letter isn't done, then then decrement the letter. I don't know if I even need to do that actually. I think I just need to continue. Yeah. Push on the stack. Stack appends the letter. If the letter is not done, I don't think I need this check, right? Because it has to be not done at this point. If the frequency of the letter is 1, answer extends by the stack. Done is updated. Stack empties. Frequency is remote decremented. Yeah, I think that's fine. Mm. Oh my God. Good Lord. A, C, B, A, B, C. Okay, what's going on here? So the stack should be A, then C, then, I mean, this B should pop the stack, so it should be A, B. Okay, I'm kind of confused here. So let's go ahead and just for every letter, print the letter and the stack. Okay, so first thing is C, and then B pops the C, A pops the B, A, C, B pops the C, so it's A, B, A, B, C. Uh, uh, this A, which isn't a final A, makes it this A, which isn't a final A. How do I want to handle this? I mean, it could be a new A. I think what I want to do here is actually, if this A goes in the stack, but it's actually at the same as the front of the stack. If it's the same as the front of the stack, I feel like that's not the way to handle it. I was going to say if this A is the same as the front, then I don't actually pop it. But what if it's like stack with A, B, C, B? Do I want to pop this C? Because the B is already there. I guess that the stack is already. I guess if the stack already includes the letter, then I don't really want to mess with it. If the stack already includes the letter. Oh, right, right. Yeah, okay. I think I need to have a stack set. So whenever I add onto the stack, whenever I pop off the stack, then I need to remove that letter from the set. While stack, and this letter isn't in the stack. Set. Yeah, because if the letter is in the stack set, then I don't want to do anything. If the letter is in the stack set, I don't want to do anything. While there is a stack, and this letter is different than stuff in the stack, and this letter is bigger than the last entry, then let's say pop the last letter and stack set remove this last letter. Stack appends the letter. Stack set adds the letter. And I think this should be stack set should be reset to empty. Oh my god. Oh my god. So much red. Oh my god. V V A B B. Did I do my logic wrong here? While the stack and this letter isn't in the stack set. Is that always true? Okay. Okay, whatever I did here, it's just not it. Not it. The okay, so what do I do here? A, B, C. So if I add another A, should I reset the stack there? Should I not? Hmm. I wonder if I could use a heap. Wonder if I can use a heap. Huh. Because I end up having only one of each, right? I mean, I feel like I should be able to use a monotonic stack. But maybe a heap is faster. Or maybe it's just less complicated. So if I did a heap, what would be the tiebreakers? Like the heap would have something like it would be the frequency of the letter is the first, and then the letter itself, maybe the index. The frequency of the letter, and then the index. Index or the letter. It might be the index where it occurs and then the letter itself. I mean, why do I need to care about the letter, to be honest? There has to be a type. I mean, the frequency and then the index. Like tuples of frequency, index, and letter. Is that right? I mean, index and letter. One. Hmm, that doesn't feel right. Okay, this is probably a bad idea. A, B, C. There's another A. Clear the stack or no? Like, is there a point? What do I gain? What do I gain by clearing the stack here? I don't think I gain anything. Like if there was A, Z, or an A, B, or an A, let's say this A, C, D, and there was an A, B here, the C, D would still, but I don't think I don't think I remove anything if it's already there. So if the letter isn't done, continue. If the frequency of the letter equals 1. Stack set. I wonder if I should just do this first. So if the frequency of the letter equals 1, then maybe I should do that first. Or should I try to clear the thing? So while stack and while there is a stack, kind of wish I don't do the pop at all. It should be something like if yeah, I mean, what was wrong with this? If the letter is not in stack set, and the last is bigger than this letter, stack pop, stack set, remove this. Oh, did I do stack set, remove the letter? It should be stack set. No, I did last, right? I did stack pop, remove the last, and then stack set, add the letter. Frequency. And why did this not work? This definitely did not work, right? So Z, Z, A. So it's going back to duplicates here. So it's going back to duplicates. While stack and letter not in stack set. So the letter is in stack set. Right. Okay. And the letter matches. Well, if the letter matches, then it should have removed the second Z. So A. Okay, let's go ahead and just do this print adding and then stack. Adding two Z's. Should only be adding one Z. So the Z is in the stack. Oh. So the letter is already in a stack set. So it doesn't pop anything. Okay, I see. Yeah. If the letter not in stack set. Okay. I think that might have been it. I need to clear off the stack set here as well, I think. I don't think, maybe it doesn't matter. Oh my lord. So many wrong answers. Oh, back to this one. Okay. Oh boy. So let's go ahead and print out the letter in the stack, I guess. Oh no, I haven't done this one before. Okay. So A, C, and then it reaches the B. And then what does this C here? It clears off. Why does it clear off? Huh. Why does it clear off? Oh, I see. It doesn't clear off. So it's this A here, and this A clears off. This A doesn't clear off the AC. Okay. Because this is the final A. The final A is either going to have AC or it's just going to be a single A. Interesting. And because I didn't do this pop of everything that's smaller than the A, then it keeps it. Oh boy. A, B, C, A. Okay, so it's like I I got to work on one of the test cases, but that generalization of how to handle repetitions doesn't necessarily always work, or isn't, what's the term? It isn't, uh, what's the logical term here? Isn't thorough? Isn't, isn't not consistent? Isn't sufficient? No, I don't even know what I'm saying now. Isn't guaranteed. All right, anyways, ACCA. So second A here is guaranteed. It has to be, A has to be decided here. There are instances where you want to have AC. Yes or no? Uh, If it was something like A, C, D, A, D, D, then you want, no, so if it was something like A, C, C, A, D, C, right? In theory, you want to keep the AC and have D, but then at that point, yeah, you want to push AC onto the answer. But in this case, it's ACC, A, B, C. So you want to just have A, B, you just want to push A on the answer. My solution just doesn't handle this consistently nor correctly. Consistently nor correctly. So this should be ACD. This should be ABC. Yeah. Maybe I need a single stack. A, C, A, C, D. Wow. Wow, 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 wow. Is there heat formulation for this? So the heat formulation is, I want to say the index of the last of something. Because I need to resolve A first, and then I need to resolve C or D. How do I even have a consistent stack for that? A, C, and then either pop the A, so it's either going back to A or it's going to be AC. But then when I have the final A, I could keep it ambiguous. Could keep it ambiguous. But then what am I waiting for? If I don't resolve the stack when the final A occurs, then when would I resolve the stack? At the very end? That doesn't seem right. Like if I can I wait until the D? But then how would I know that D is when I resolve things? It's just the final instance of the letter. I mean, maybe it's the final instance of the letter while the letter is not in the stack. If it's on the stack, then if it's on the stack, then it should represent that it's optional. Should represent that's optional. Oh my god. Oh my god. Am I really gonna get stumped by a medium? been so long. Thought I was safely in the sub-hard above medium tier. Fuck. Okay. ACC. ACCA DC. ACCA BC. Push A, push C. Second and last A. Keep AC. Keep just A. I keep the A. Keep just A. If there's a smaller thing than C that can be pushed into the stack, I don't keep. I keep one and only one, huh? Lexicographically small subsequence. So all the duplicates. So C1, C2, C3. C1, C2, C3. Maybe it just is heap. Maybe it just is heap. Right. Maybe it's a heap. Heap by what exactly? Um, so C A, gosh, heap letter index, and there should be some sort of frequency. So that just can't be right, or that just is not enough information. Letter than index. I mean, I want to take the A. Maybe it should be frequency somehow. So there's two A's, two, three C's, and a D. So there's single B. So the B has to be there. So if I take from the heap the lowest frequency, or I take from the heap everything that has frequency 1, I start with that. How would I even build my array? How would I even build the answer? All I knew was just the positions. Huh. Am I doing this? I mean, this is kind of a small, this is kind of a small string length. I wonder if I'm actually supposed to be doing something like dynamic programming for this. Am I supposed to be doing dynamic programming for this? Like a 26 by 1000 matrix somehow? 26 by 1000 matrix. Uh, I feel like that. A for every index and every letter. For every index and every letter. Smallest lexicographical string up to that index. Using the letters. Using those letters. That thing. I mean, in theory, if this is a monotonic deal, then you could have a very, very long string and it still would run in time since it's basically linear. So, I mean, I should be able to do something much slower than this, like even n squared, and it should still be fine. So maybe I'm just trying for something that's not actually possible, because this is really fast if the string is just 1000. Oh, yeah, I mean, this 1000 length would be something like n squared or lower than that kind of. Could be n squared log n. Even sorting it would be n log n, which is perfectly fine with 1000. I'm not sure. I mean, sorting would be like heaps. Heaps would be n log n. Then if it was heaps, then even something that was 10,000 or even 100,000 would be fine. That's the length. Yeah, this is like not, this is allowing for something slower than heaps or slower than sorting. A, B, I know I have to have A. I know I have to have A. At that point, I either have B, how would I do heap? C. So if I were to have a tuple for every value in the array, every letter in the array would be is the index, the first tie break, frequency, the letter. I mean, if it's indexed, then the heap is just going to be the same thing as processing character by character. I think it'd probably be character. So I start by looking at where my A's should be. Is that how it should go? I look at where my A's should be, and I say that the earliest A is the better. So therefore it should be A at index 0. And then I look at where my B's should be, and it should be the earliest B that is after the A. So it should be B at index 3 or 4. 0, 1, 2, 3, 4. And then I look at my index where my C should be, and it should be the earliest C that is after A and B. Is that right? The earliest C that's after A or B. So why would I? Yeah, it's earliest C after A or B. But if it's not, then what would I do? Earliest C after A, earliest C after B. But what if my earliest? What if my latest C is like? So in theory, I want the 5C. So I want the earliest C that is after B. But then what if that's then what if it was something like this? What if it has a Z and the Z has to be before the A? At that point, I want the C that is before the Z. So I can't process it by just alphabetical letters. I don't think, unless I'm willing to reprocess it later on, because the Z makes it, yeah, makes it want to have something smaller than it before it. Yeah, that's so the heap processing by the lowest character might not work. Heap processing by lowest character. Then maybe I start by not having non-optional stuff on the heap. So if there's only one character at a certain thing, then I just say that has to be the thing. So Z has to be 1, and then A, so assuming Z is not in the heap, I guess in this case B is not in the heap either. B is going to be 1, 2, 3, 4, 5, 6. So then A is now determined, and because A is smaller than the stuff that has been determined, then A should be, well, A is smallest, so does it ever make sense to not pick the first A? Probably not. So you just pick A is equal to 1. So the heap has now values that are like A at index 2, A at index 5, C at index 0, C at index 3, C at index 4, and C at index 6, no, 7. So you pick the earliest A. I think you always pick the earliest A. And then you pick C. So in this case, you pick the earliest C because the C is smaller than the Z. I guess. So maybe you have two heaps, a heap for, no, that doesn't make sense. Z before the Z before the Z. Right now it's supposed to be C, D, A, B. A, A. What do I want? What do I want? Z has to be taken. The B has to be taken. So Z is optional, Z optional, B optional. And because Z is such a low number, anything that is optional before it that is smaller than it has to be taken. Then you get back to the thing where it's A, C, C, A, B, C. So sometimes if it's optional, so the second one is not optional, or it's optional if, well, ACCA has to be resolved. It has to be resolved into some ambiguous state because you actually don't know if you want to see or not. Sometimes you do, sometimes you don't. So it's like A, can you keep AC on the stack? If you keep AC on the stack, then here you get ACD. Keep AC on the stack, then here you get ABC. Maybe you should only, so maybe you should keep AC and do what exactly? So it's A, C, D. Maybe you should only push the stack onto the answer once you try to pop something that's not optional. So you do A, C, D, this C technically doesn't cause a reset. So if you push something that's not optional, I wonder. While stack and letter non-stack stack. If I were to try to remove something that is, so it would have to be, if I were to modify it so this A doesn't actually resolve the stat, then I would have to remove this thing. And then the resolution has to occur where? All right. This is wow, more than an hour.